Imagine typing your password into a login box and hitting enter. With plain HTTP, that password travels across the internet as raw, readable text. Any attacker on the same Wi-Fi or anywhere between you and that server can read every single byte. No encryption, no protection, nothing. That's the problem HTTPS was built to fix. Now, before your browser and server exchange any real data, they run what's called a TLS handshake. So, first things first, the browser sends what's called a client hello, basically saying, here's every encryption method I support, pick one. The server picks a cipher and sends back its certificate. The browser verifies that certificate is legit, and here's where it gets clever. Both sides independently calculate the same session key. They never send it across the wire. They just calculate it separately and get the same answer. The channel's open, and the whole thing under 100 milliseconds. Now, that certificate the server sends, it's actually more interesting than it sounds. It contains the domain name, so your browser knows it's talking to the right server, not a fake. It holds the server's public key, the math that makes the key exchange possible. It carries a digital signature from a certificate authority. Think of a CA as a trusted stamp of approval your browser already recognizes. And it has an expiry date, so old or stolen certificates can't be used forever. Put that all together, your browser can say, yes, this server is exactly who it claims to be. But wait, how does your browser trust a certificate authority in the first place? It comes down to a chain of trust. At the very top sits a root CA, a small group of organizations whose certificates are pre-installed in your operating system. Your computer trusted them before you even turned it on. That root CA signs an intermediate CA, which then signs the site's certificate. Your browser walks up this chain, checking every signature, until it hits a trusted root. If the chain holds, connection proceeds. If anything breaks, security warning. Once that handshake's done, something fundamental changes. Your browser and the server now share a secret key. Nobody else in the world has it. Every byte you send, passwords, form data, cookies, it's all encrypted with that key before it ever leaves your machine. To anyone watching the network, complete gibberish. The server's the only one that can decrypt it. That's the encrypted tunnel. And that's what HTTPS actually is. So, here's the full picture. Your browser looks up the address, runs the TLS handshake, and verifies the server's certificate through a chain of trust, all the way back to a root CA. Both sides derive the same key without ever transmitting it. And from that moment on, every byte is encrypted. That tiny padlock in your browser's address bar, it represents all of this happening invisibly, in milliseconds, every time you load a secure page. Pretty cool, right?